So for question number 9, it's asking for the third time. At high altitudes, a proportion of oxygen drops. This is false. The proportion of oxygen stays the same. But what is the difference? Answers on the board. What is the difference at high altitude? So oxygen stays the same, but when you go up, what happens to the
atmospheric pressure?
The pressure, right?
Gets more dense.
So the pressure of oxygen decreases. So oxygen is concentrated equally in the sky. On the mountains and in the ocean, oxygen is not in the ocean, but you get what I'm saying. At sea level, it is the same, proportional. But the difference is pressure. If you don't have outside pressure, the pressure from the outside is less. Is the oxygen going to go in you more, or is it going to? What's going to happen if there's not enough pressure, right?
If there's not enough pressure, it's not going to go in.
Yeah.
It's
not going to go in. It's just not going to go in.
Exactly.
Yeah. Does that make sense? So so let's think of let's see. If you stick, I'm trying to think of a balloon, but I'd have to think about that. But does that make sense? The more pressure on the outside, the more it's going to go in, right? High concentration to low concentration, right? Because we have low concentration in us. Right now, we are at a high concentration of oxygen. So this is why oxygen is able to go into us, because all pressure movement. It's not like we're not having, to work hard, right? So it's all pressure. So the pressure is less. This will cause oxygen diffusion. That just means diffusion. Whenever you see that, it means movement. Oxygen movement will be slower. So if oxygen movement is slower, is hemoglobin going to be more or less saturated? Less saturated, yes. Did you look at the board?
No.
Oh, good for you. Okay. Sorry. I like picking at your brains, so this is fun. So question number 10, what is false of carbon monoxide? Can you die from it? That's, yes, you can. If, carbon monoxide, like if you don't have, do you do stuff with cars?
Yeah.
So what is that what's carbon monoxide in your car? Is it like a filter? No?
What?
No, when you get carbon monoxide poisoning from sitting in your car,
Yeah.
what's wrong with your car?
It's not so much that there's anything wrong with it. It's the fumes and the vapors that are coming off of the exhaust, and it smothers out the oxygen.
Right. So carbon monoxide.
Intake all of the pollutants, and it smothers the oxygen in your body, so you just basically suffocate.
Yeah. So that was a very lovely description. So now knowing that it is caused by lack of oxygen, right? So the false question to number 10 is B. It says carbon monoxide can be treated with exposure to high carbon dioxide. No, that'll kill you. Don't. So to make this true, carbon monoxide can be treated with oxygen therapy. You want to give more oxygen because their lungs are suffocated because they're breathing in all the pollutants and toxins and fumes. So, but all the other ones are true. So let's see now. Number 11, why does carbon dioxide diffuse out of the tissues and into the capillaries? So why does this happen? Can you guys see that okay? I'm going to zoom in. Hey! Woohoo! Okay, it's big now. Okay. So the reason why oxygen diffuses from the red blood cell into the tissues is because the concentration of what is higher in the tissues?
CO2.
CO2, right? It's an acidic substance, right?
Blood is higher in concentration, so it's moving to a less concentrated area. So the oxygen is going in, forcing the carbon dioxide out.
Exactly. That's right. Does that make sense? Because the concentration of oxygen in the red blood cell is more than the tissues, right? So it's going to go from a what concentration to high to low. This is all pressure. So the reason why carbon dioxide diffuses out of the tissues and into the capillaries, so capillaries are small blood vessels. Does that make sense? Okay. Because the tissues have a higher concentration of partial carbon dioxide in them, and because the capillaries have a lower concentration, right? So it's going to go from high to low. So high oxygen in the blood is going to go into the tissues that have a low concentration of oxygen. High CO2 concentration in the tissues is going to go into the blood.
It's kind of like a teeter-totter.
Yeah, exactly.
This one.
Do you guys follow? Do you have any questions? Speak up if you do. So it's usually if you memorize just one of these concepts, whichever one is easier for you to, the other one, just think of it happening opposite. That's actually a trick with anatomy. If you have to memorize like hypo something and hyper something, the only thing that doesn't work is with electrolytes. But if you have to memorize like hypotension and hypertension and all this other stuff, just memorize the one concept and just think opposite with all the others. So as you go through anatomy, this will come up more often. So number 12, how is the majority of carbon dioxide transported in the lungs? So carbon dioxide is transported to the lungs as bicarbonate. So I'm going to erase this. I don't know if you can see that. Yeah, you can see that on there. Okay. So when you have, I'm going to throw an equation on the board. Don't freak out. Please don't. So you have, what's CO2?
Carbon dioxide.
Okay, what's H2O?
Water.
Okay, what is, and this turns into, oh God, what is it?
H2.
Yeah. CO3. This is, do you guys know what this is?
I should, but don't.
It's carbonic acid. It's just kind of, when you see the 2 and the 3, just think carbonic acid. I don't know how much else. It's an ion, but this isn't a chemistry class, this is anatomy. And then this turns in, oh Lord, I don't have enough space. This turns into, what is this?
Hydrogen.
Hydrogen and,
Bicarbonate.
yeah, HCO3. So whenever you think, so this is pretty easy, right? Carbon dioxide, H2O, that's a big O, it's supposed to be water. H2O is water. H2CO3 is carbonic acid. H is a hydrogen ion. HCO3 is a hydrogen ion. So you're gonna be chemistry SI. How can you tell that they're ions?
Because of the plus and the minus.
Right. So if you're taking an exam, a good way to see if I'll make that prettier. You guys can all read my chicken scratches, right? Okay. A good way you can tell if it's an ion is if it has the positive or negative at the top. Okay? So I know a lot of people get bicarbonate ion confused with carbonic acid, but carbonic acid, does it have anything up here?
No.
No. So that's how you can kind of memorize it. The one without the plus or positive or anything is the acid, okay? And this is the one in the middle. So the majority of carbon dioxide is transported to the lungs as bicarbonate ion. So what is, you're kind of reading this and you're like, well, what the heck does that mean, right? So there are three ways total that carbon dioxide is transported in the blood. It can be transported, well, you can look at the other ways it's transported. I think they're mentioned in the question. Bound to hemoglobin, they're transported as that. They can also dissolve in the plasma, but the majority of carbon dioxide is transported in the blood as bicarbonate ion. So you have all this. So this is how carbon dioxide becomes bicarbonate. So carbon dioxide comes into the body, right? You breathe it in. No, you breathe it out. No. Sorry. Quick thing. So you breathe oxygen in and all that happens. Now we're starting at your cells, okay? Your cells have carbon dioxide in them. Carbon dioxide leaves the tissues, right? Goes into the blood and combines with water, because water, plasma, is in your blood. When this happens, they combine, they form what is this?
Carbonic.
They form carbonic acid, and then when carbonic acid gets to your lungs, when the carbonic, okay, this is in your red, I'm sorry, this is in your red blood cell. Okay, so carbon dioxide binds to the water in your red blood cell. Inside your red blood cell, this becomes carbonic acid. So H2CO3. And then carbonic acid will split, right? Because you have all these molecules in here. Carbonic acid will come apart into hydrogen ions and bicarbonate. So you see, so CO2 is carbon dioxide, but you can also see CO3, right? It has CO2 inside of it. Does that make sense? So most of it's transported as bicarbonate ion. Now we're going to go through the sequence of carbon dioxide transport. This is where a YouTube video might be helpful, but I'm just going to walk you through it so you can if you have questions, definitely ask. This part is usually one of the harder concepts you will learn. If I can find the eraser. So we're going to start in the plasma, right? So this is your plasma. This is like your blood vessel, okay? And it's going into the red blood cell, okay? Okay, so CO2 is released by what? What's it released by? Yeah. It wasn't a trick question. I know. It's
I know this.
I know. It's not a trick question. It's all repetition. So this is gonna all sound very much the same, but this is just to learn the concept. So CO2 is gonna come out of your tissues, and what tissues do you have in the body? What tissues? You have muscle tissue. You have brain tissue. You have all sorts of tissues. So all tissues do this, and they all need oxygen. So your tissues are going to have their waste product, right? This is like CO2 waste, okay? It's going to go from the blood plasma into the red blood cell. This is not proportional. This is just for visual references.
Visual effect.
Inside the red blood cell, carbon dioxide will combine with water, to form carbonic acid. So let's see, I'm thinking about colors now. So you got CO2 in your blood, red blood cell, plus in your red blood cells, all your cells have a ton of water in them. So the water's already inside your red blood cell. So carbon dioxide is gonna combine with water, and it's going to form carbonic acid, which is H2CO3, okay? This is like that equation, right? We're moving from left to right, okay? So it's going to form carbonic acid. Carbonic acid is then going to, it's right here, the equation, okay? Something to keep in mind is that the enzyme carbonic anhydrase is what causes them to stick together. So whenever you see the word, so in here it says anhydrase, what does the ACE usually indicate?
Enzyme.
It's an enzyme, right? So carbonic anhydrase glues carbon dioxide and water together to form carbonic acid. Carbonic anhydrase forms carbonic acid. Moving around. So you're still inside the red blood cell. Carbonic acid will then split. So how are we gonna do this? So carbonic acid is going to split apart, and it is going to split into what?
Hydrogen and bicarbonate.
So, so what is bicarbonate? Yeah.
Bicarbonate.
Yeah. What is
HCO3. Yeah.
And what is hydrogen?
H+.
H+. There you go. Right.
Oh, Lord.
Okay? So it's going to split apart, and then bicarbonate ion. Yeah, so this reference right here, does that make sense of why it happens? And there's a picture in your book that shows this. That picture is a scary picture. It is a very terrifying picture. This is much simpler. This is why you come to SI, okay? So yeah, this is kind of walking you through it like how it is. Ignore that picture. I mean, if you understand it and you just want to look at it, then you can look at it for fun. If you find that fun, I find it fun. But if not, cartoons. If you don't understand it here or you kind of forget it, hopefully I'll get this uploaded. And if not, look up YouTube videos, crash course, definitely. So this is when I went through the carbonic acid, how to tell the difference, the negative or positive ion. So here's the positive, here's the negative. That means it's an ion. There's no positive or negative up here, so this is an acid. And these letters, so you get the words, the name of it, carbonic acid, carbon dioxide. These are the molecular equations. So if you haven't had chemistry and you see that like in an exam, it's just asking you for the letters. Does that make sense? Mm-hmm. So it's like, give us a molecular equation for carbon dioxide. And you're like, oh my goodness, what am I reading? It just wants you to put CO2. So it's just kind of nice to fancy science for those letters. So now we are in the blood plasma. Okay, this is the second part. So the bicarbonate ion, which is this green, will how does gases, how do they move? What is that called? That process? Diffusion. Yes. So bicarbonate will go into the plasma, which is, your blood plasma. It's just the liquid part in your red blood cells make that up too. And a concept that probably will come up on an exam is called carbonic or chloride shift. I'm sorry, the C's are all in my head. So you have a concept known as the chloride shift, okay? So if a negative, I know if some of you haven't taken chemistry, you're looking at me like, what are you talking about, girl? Hopefully I'll upload this video. This is one of the hardest things you will learn, besides the endocrine system. So maybe if this video comes up, that should help. So I'm not trying to call you out, I'm just saying I noticed. So if something negative leaves somewhere, okay? So just say, so you're on a budget, right? You have some positive, positive plus. You have some positive, what is that called? Positive money coming in, and you have negative money coming out, right? So this is like your bank account, right? So if you lose some, you also got to gain some, right? To make sure it's balanced. So when you lose bicarbonate, you have chloride. You have kind of chloride ions. An ion just means it's positive or it's negative. It's just, if you don't know chemistry, just the positive or negative. Chloride is just an ion. It's kind of hanging out in your bloodstream. When you lose this bicarbonate, chloride has to go into your red blood cell to balance it. It's kind of like a cycle. So when one goes in, one needs to come out. It's like a bank account, right? As you lose some, you need to gain some, because if you end up getting negative, yeah, thank you. English words. If you end up getting a negative, you're gonna go bankrupt, right? That's okay, got it. I don't know if that analogy makes sense. So this is known as the chloride shift, right? Chloride is shifting as bicarbonate comes out. And then this leftover hydrogen ion, so this lonely ion that we're not doing much with, it's just gonna bind to hemoglobin and it'll just kind of hang out there. So now the next part is in the lung capillaries. And so this was in the body, right? All this badness happened in the body. So now we're going to so now this red blood cell, just imagine it just flowing through your body, and now it's coming by your lung capillary. So this is your capillary. And capillaries are really small. So this one is smaller. Does this make sense? Okay. So it's flowing through your body, throughout the veins, and now it's here in your lungs. So now we're going to work on moving from the plasma into the lung capillary, because when it gets into lung capillary, where's it going to go? Because we want to get that waste out, right? Feels good. We want to breathe. So bicarbonate ion and hydrogen enter the red blood cell at the pulmonary cap. Oh, right. Yeah, because you have red blood cells in here. That's right. So you just have them kind of going through. So you're going to have bicarbonate. So you have in your blood, this comes from many
red blood cells.
Many red blood cells, thank you. It's going to, oh Lord, there's no red blood cell there. It's going to move into your red blood cell. Okay, minus, because it's an ion. And then another thing that's going to go into the red blood cell in the pulmonary, because whenever you hear the word pulmonary, what are you going to think of? Lungs. Yeah. So you're going to have bicarbonate moving in, as well as what else? Hydrogen, yeah. And what's hydrogen? Which one is hydrogen? The H, yeah. The orange one. Oh no. Yeah. Okay, so hydrogen's gonna move in there too. Okay? Oh Lord, okay. We gotta go through a whole nother process. This is gonna be fun, okay? So I've recorded this. It has this. Does anyone want to take a picture? Because I'm going to erase this. Okay, because this, I'm just gonna make this bigger because this is too small to work with. Are you holding up okay? I can see you're a little bit like, what is going on? But hopefully rewatching this. Oh, okay. Introverted. Yeah. That's good. That's good. We all need introverts. They don't listen to us when all of us extroverts are like talking our mouths off. So it's a good thing. Both are good. So I'm gonna erase this, okay? Because I'm gonna make this so you understand. This is the plasma. This is in your body. This is your pulmonary capillary, right? I'm just gonna make this bigger. So away with you. This is your lung capillary. This is your plasma, okay? This is your red blood cell. And now I'm making the lung capillary bigger, okay? So pulmonary. Does that make sense? I don't want to confuse you. Okay. So you're going to have bicarbonate ion in your plasma, right? HCO3 minus, because the minus indicates it's an ion. And you're going to have hydrogen ion just kind of hanging out in your red blood cell. This is going to go into your pulmonary capillary. This was actually perfect, these markers, because there's a lot of color coding. So thank you, I appreciate that. So this is in your lung. So bicarbonate ion, or hydrogen, and HCO3 minus, so these are both ions, right? They're gonna go into the cell of your red blood cell, right? And when they're inside the cell, what are they gonna do? So do you guys remember that equation, how we went from left to right? Now we're gonna go from right to left. So we start with let's just do a brief little recap. Sorry, I know we're all excited. Hydrogen. Okay, so you have carbon dioxide, and what does that combine with? Water, okay. H2O. This is gonna form what?
Carbonic acid.
H2O. H2CO, right? H2CO3. Okay, carbonic acid inside the red blood cell. Now we're over here. It'll then turn into carbon dioxide. No. Trick questions. I was trying to test y'all. It's gonna turn into hydrogen ion and bicarbonate. Yep. So we went from this way to this way, and that was all from in the plasma to the red blood cell, all in the plasma. So left to right. Now we're gonna work this way. You start with hydrogen and bicarbonate,